Alright, hello everyone. My name is Tian. I'm a part of Team 16597, Fulminata, and today I thought I would do a little presentation on how to get TensorFlow working with FTC machine learning. So to do that, it's not terribly complicated, especially if you only want to get the camera working so it can see the bolts, the bulb, and the panel when it comes to that cup. But we'll also be covering how to make it recognize your custom sleeve or custom parts or whatever you might want to recognize. For example, we have it working so that it recognizes the red cup on the playing field. So that is a little bit more complicated, but I should hopefully walk you guys through it, and hopefully it should go well. So I have a little slideshow, and I will have all this linked, I believe, down in the description if anyone of you wants to look back on this later. And the slideshow should hopefully cover most of what you need to know. So these are all the resources. This is the documentation. This is what I went to for everything that I needed to know. And if you don't understand something that I'm saying, or you just want to go into further detail, the documentation is a great place to start. And then the FTC Machine Learning Trainer, that's the link where you're actually going to train your custom files, models. And then this slide, and this should have most of the information that you should need. And then there's me. My name's Tristan Fulminata in full, and my Discord is TNTN #7332. Feel free to reach out if you need any help, but do please check the documentation before doing so. So we can get started, and the first step I've kind of put into 5 separate steps. I will go through all of this myself, but to just give you a quick overview, I will be covering all this in Android Studio, but I know it is possible with on-bot Java. When it comes to doing blocks, I have no idea if this will work or not, but I know that you can get it working with on-bot itself as long as you're programming in Java. So first things first is to actually get the example file, which I believe is in the SDK on Android Studio. When it comes to on-bot, I believe it is found when you're making a new file. There will be some ones that you can just copy basically, and you can find those in the samples. And we're looking for concept TensorFlow object detection webcam. And if I switch over here, hopefully that is showing you guys Android Studio. And you can find this up for Android Studio at least. It's a bit hard to see, but right here where it says FTC robot controller, you open up that file and you go into Java, and then there should be external samples. We'll just open that up. And in this case, we're looking for concept TensorFlow object detection webcam. There's also an available option without the webcam at the end, and this is for if you're using a phone, then you can use that instead. But in this case, our robot does have a camera. I don't know the major differences between the two, but I'm pretty sure they are fairly similar. So we're going to take this file, and we're going to go down here to team code, and you can see that there's a Java folder in here. We'll open that up, and we'll go into our org, first inspires FTC team code. That's where all your op files should be, along with, I believe, autonomous modes. So we'll drag and drop our example project and put it directly into our team code project and refactor it if need be. So now we should have a file that looks like this. And I believe the next step would be to, can I get this right? There we go. It would be to go to disable this, to comment out this disable line on line 53. So if we take a look right here, right here, should say disabled. This is in, I believe, most, if not all, what's it called? Example op modes. So we can just disable that or take that out. So that way it will run fully. And now if we come down here, we can see that, well, first of all, I believe it is line right here, 167, where we have to set our device. So this is in the configuration of your robot. You should have your webcam set to whatever name you picked for it. In our case, we actually have it set to webcam 1, so that will work great for us. But if you need to, just change this to whatever you have it set in your robot customization, or something like that. And then lastly, we have to add our Vuforia key on line 86. Now this is slightly complicated, but not terribly. It's all explained right here. So basically you have to go to Vuforia. That's what TensorFlow kind of relies on. And you have to go to the website and get a key. It's completely free. You just have to make an account, and you should be greeted with a 380 character long key. And you would paste that right here with no spaces between these two commas, or no, they're not commas, but these two little things right here. So I have a key, but I'm not going to put it in so that people do not copy it, but it would just go directly into here. And then I believe that is everything that you would need to set up just the camera so it can detect the 3 different images, the bolt, the bulb, and the panel. So if you run this op mode, you should see on your driver hub, it says it will detect whatever is put in front of it. And it should, if it worked, look something like this. So you can see here. Oh, sorry, that's not it. Let's go back. So this is the documentation. This is where it shows how to do everything. It should look like this, where it can see the bolts and the 2 different bolts. And sometimes it'll detect the 3rd, but as long as you have typically more than one, but even if you have one, you're good to go. And it of course works for the bulb and for the panel. Now you might just have text instead of the actual camera, but either way, it should say that it detects what it needs to detect. So going back to our slideshow. Did that do it? There we go. So hopefully that's working for you, but now we'll actually get to going through this with a custom model. So that takes quite a few more steps, and we'll break this one down all the way too. So step number 1, do all the steps listed before. You need to get all that working and that op mode working, but now we're actually going to customize it to how we want it to be. So second step is we're going to take a video of whatever object we want to detect. So if this is your custom sleeve, that's great. If this is the red cup or the blue cup, go ahead and just take a video. You don't want this to be terribly long, and you don't want this to be terribly high quality. So what we do and what's recommended is to just use whatever camera is going to be on your robot. For example, we just have this Logitech little webcam, and just take a video straight with this thing. So what we decided to do is use our camera app on our computer. So just hook it up to our computer. Here, I can show it like this. And just basically, let's say I want to get this peach in so that our computer can recognize it, our webcam can recognize it. Just go around it and take a nice little video from a lot of different angles. You don't have to go straight on top because your robot's probably never going to see it from that angle. And if you have your robot fully built and the webcam set up, you can just drive your robot around it, and that way it's always capturing it from the angle it needs to see it from. But for us, we didn't do that, and try to keep your object in screen. If it's out of frame, it's not going to be a great quality footage. And you don't want to exceed anything above, I believe, 1,000 frames. If you do, that's just a bit overkill. And you can overtrain these models. I believe 700 frames is about the sweet spot, so aim for that. But if you don't quite hit it, that's not a big deal. I think 500 should work. And keep in mind, you're going to have to label these frames one by one. So I would suggest using the lowest frame rate you can, but then taking as long of a video as you can without exceeding, 900. In my case, I believe my first one was about 900 frames, and you can see that here. So that's our next step if I switch back to our slideshow. So you can see the next would be to upload to the actual website where your model will be trained. And this is fairly easy. The only complication is that only your coach is allowed to upload the video. And I believe that's put in to enforce safety, but I don't really know why that's exactly there. And honestly, it's slightly annoying, but we get around it. Just have your coach upload it. This should be highlighted and able to click on for them, but for us, it is just grayed out. And once that is done, once it's uploaded, you can get it from any device. So I'm on my computer now, and you can see this. You shouldn't see all these different numbers. You should basically just see that it's FPS, how many frames are in the video, and you'll slowly start to extract each frame. So you just have to wait for this number to reach this number. And once they do match, this should turn blue and be highlighted. So we can click on this, and this is now a link. And this is how you actually can track your objects. So track and label your objects. So you can see here, this is my video. And my video wasn't terribly well done, quite honestly. But we can watch it here really fast, just so you guys have an understanding. Because it still worked great, so don't stress too much about your video. But do keep in mind that you do want it to be as nice as you can have it. So it's quite a bit longer than you would need it to be, but you can see that I just took it from a lot of different angles. And you can see I also did have it quite off frame at quite a few points in time, but we'll learn how to deal with that in just a moment. So if we go back to this website, I've already gone through all of this for my cup, but basically you would label whatever you need to by drawing a box around it and then coming up here and labeling it. So for example, this strip of electricity, this electricity splitter, we can label that, or we can label my charger, or whatever we want. But in this case, we're focusing on the red cup. And you can see I have it labeled right here, and the box is drawn around it. Now it is off frame a little bit, and personally, I've did almost all the frames where they are off frame, and it ended up working out well. I don't think that this is actually recommended, and I would suggest that what you want to do is just use all the footage where your object is actually in frame, because it is making a model that it can recognize. So if you have your model off frame, I think it should still be able to recognize it even if its model is fully made for it in frame. But let's say that you have your model really out of frame like it is here. In my case, I still labeled it, but I actually hit ignore frame right here. And this is just going to say we're not going to use it. I know it's labeled, but it's fine. And you can even do that when it's not labeled, like I am doing here. And you can just go through your entire video and label it one by one if you so please. But luckily, we are given the option to track with OpenCV. And we can see the algorithm here is set to median flow. Great. But we can set it here to CSRT, and that is what I personally think is the best. There's differences between all this, but CSRT has worked best for me. You basically just want any that will keep the box around your object and not make it too wide or too small. So we can just press start tracking now. And I've already gone through all this, but it'll still track over it anyways. And it'll take a minute to get started. But once it's started, it will start going decently fast. So give it just a minute to load. It's taking slightly longer than usual. There it goes. So it will do its best to keep your item in frame, and it'll go one by one. And you can see it's doing a pretty good job. If it were to get sidetracked, like it is now, see it's not at the top. Typically I'd let this slide, but for demonstration purposes, we'll just stop it and we'll adjust the frames. And if it gets really bad and it's already gone past quite a few frames where that's messed up, you can just stop it fully and then go back and readjust it and fix its mistakes. But for the most part, as long as you keep your item in frame, this should do a pretty good job at tracking it. So I'd say just mainly rely on this because going through 900 frames would take a long while. And all this is automatically saved, so once you get to the end, don't worry about saving it, just you can hit the back arrow and it'll all be good to go. So you can see here, I've labeled 944 frames and I've excluded 24 of them. So that's just the amount that I've hit ignore on. And what we can do now is just select that video and click produce dataset. And I set these numbers to 80 and 20. And I got this from the documentation, but you can do with the default 90-10. It's up to you. I think that 80-20 is the preferred version though. So what this basically does is 80% of your frames will be put towards training the model, and then 20% will see how good your model actually is, and if it passes those different images, then you're good to go. And we'll also add a description. So in this case, it'll be red cup. And then we'll hit produce dataset. I won't do that because I've already gone through this process, but once you do that, basically this will just take a minute to load and you'll be faced with something like this. So just make sure you move from your videos tab to your dataset tab. Now the main thing you want to look at here is just at this label and make sure that it only has red cup or whatever labels you added. Keep in mind, you can add multiple labels in your video. So let's say I had a red cup and a blue cup I wanted to label. I would just draw boxes around both of them and be good to go. And you can also combine multiple videos when you're producing a data set. So let's say I made a video for my red cup and a video for my blue cup. I would select both of them and then produce the data set. Or if I had two different videos of a red cup, I could combine those two into one data set. So here we can just press the check arrow and we can go to start training. Now the big thing is actually when looking at these labels is to make sure there's no misspellings. Let's say you had RE cup, for example. That would be a misspell and you would want to go back and fix that. But as long as everything looks good, you can select it and do start training. Now this is very important, and I will be going back to my slide for this. When creating your model, you are given a maximum of 600 minutes to train. And this sounds like a good chunk of time, but it took about 50 minutes just to make my one and only model, and it wasn't terribly worth it. So a big thing about this is practicing isn't really a good thing to do, unfortunately, with this thing, because you don't want to eat up all your time. Training on GPU is expensive, and Google has given first teams an amount of time that they can, train on their GPU, but unfortunately that time is not unlimited. So if you do need more time, I believe there have been people that have gone to first and asked for more, and they have been granted a bit. But I wouldn't suggest, eating up all your time before season actually starts. And this should be enough time to make 2 fully good to go models. And keep in mind, you can label a bunch of different objects in those models anyways. So I think that should be hopefully enough for each team. Just make sure you have that in mind. I'm actually trying to get this working on a local computer where I'm training it, because I have a 3060 Ti GPU, and that's going interestingly. And I will be talking about that a little bit more at the end, because I do kind of need some help on that. But going back to this right here, this is how much you want to train your model. So set to 3,000. If you were to do 4,000, whatever you want. I believe you can overtrain it, but this is a little bit more generous than actually taking too many frames to overtrain it. So we can go down to this advanced tab, and I like to set this to something like, in this case I would do 70, because you can see down here, this job will take approximately 50 minutes. So I just want to make sure that doesn't get stuck or something, or eat up my frames, or eat up my minutes, just as a precaution. So if it hits 70 minutes, it will stop, and it won't eat up anymore. And then from there, you can add a description and press start training. I won't be doing this because I don't want to eat up my minutes, and I've already done it. But once you're done, it should come in. You should be able to come into this models folder and see over here that the job has succeeded. If it doesn't say that, go check out the documentation, or make sure that it's actually finished. You should see steps completed is the same as your steps requested, or that the training time has hit the amount that you set for it. So keep that in mind. Hopefully it's succeeded, and if so, what you can do is come down here to the check mark, check it, and then press download model. This will download a, I believe, TF Lite model. Oh, I am so sorry. I'm realizing I'm not showing my actual screen right now. There we go. So you'll come down to this models tab, and you'll do the check mark, and hopefully it's succeeded here, and then download model, and you'll download a TF Lite, so TensorFlow Lite, and you should see this in your folder right here. So this is the actual model that you want, so we'll rename this to, I believe it was Red Cup, because that's what the model is modeled after. And that's good to go. So what we want to do is we want to bring this into our, I believe, robot controller, or what is it called? The control hub. So to do that is pretty simple. All you want to do is get a USB-C cable, plug that directly into your control hub, and then put a USB, just connect the other side of the USB directly to your computer, and it should show up kind of as a, I believe it is a USB stick. So for example, I can basically just demonstrate with the USB stick. So if I were, there we go, it took me a minute. If we switch back to here, you can see, I believe I have a USB stick on my device somewhere. There it is. And you should see a folder called first, and you can open that up and add whatever folder you want. So for me, I have custom models, or you can drop it directly in there, but I like to be a little bit more organized. So just put that into custom models, and we'll also copy this directory just to make sure that we have that. And also keep note of whatever you named your file, because that will come into importance later. And now from there, what we can do is actually edit the code itself. So if we go over to Android Studio, and we go over to the file that we've already edited earlier, what we can do here is actually go through and tell it to use the file that we just created. So if we go over to, I believe, let me check the actual line. Oh, if it will let me go on to the next slide. There we go. So comment out to line 63. So if we go over to Android Studio, right here. So Android Studio gives you an either or option. So you can comment out this line and uncomment this line. And that basically just switches it from a TensorFlow model file, from an asset to a file. So it's just a different form of what it's looking for. and we're not worrying about this. This is what we want to use, and this is where we'll paste that directory. So it should always start with the SD card, and then it should be something like, there we go, first, and then make sure that the slashes are the way they want it, so like that, and then custom models, and last but not least, we'll add our, I believe it was red cup dot TensorFlow light. And that should just tell the program where to actually look in the control hub to find our model. And then after that, we can go down to here, and line 187 will comment out this load from asset, and instead uncomment the load from model, or load from file, so sorry. And this is what we want, that corresponds to the variable up here that we just changed. And then lastly, we also want to go to this strings, these labels, and switch them from the bolt and everything that they have to whatever we labeled it back in the machine learning website on first. So we had it labeled as red cup, so I'll put in red cup there, and if you guys wanted to add more, then all you have to do is add a comma and say blue cup. But in our case, we only want the red cup. And from there, theoretically, your op mode should work, and it should be able to recognize whatever custom model that you have. So if that doesn't work, check the documentation, contact me, or check out the slide in case I miss something or mess something up. But I think that should be everything that you need to know to get a custom model working on TensorFlow Lite. So yeah, there you go. Now, I do want to talk a little bit about getting the GPU working on a local computer. I'm trying to do that personally, and it shouldn't be terribly complicated, but I've ran into quite a few issues when trying to get it working. So we only need a TensorFlow Lite file to actually put on our control hub, and to train it, there's a decent amount of documentation on how to do that. But once we have that file, we're basically good to go. But actually getting that trainer has been a little bit hard. So there is documentation, like I've said. Just every single time I've gone through it, I've gotten an error of different types, different kinds, and I can't really find any actual way to fix that. So if you guys are interested in getting this working on your local computer, let me know, message me on Discord. And if you find out any way to get the trainer actually working, then that would be great. And from there, I think I shall open up YouTube and see if there's any questions. Doesn't look like much. All right. Well, I believe that should be everything. So let me know if it works. Once again, we are team 16597, and let me know if you need any help. I'll keep YouTube updated if I find anything out on training it locally, and I hope this works for you guys, and I hope that it helped. So thank you so much for watching. I appreciate it.